We're interested in the force of each member of the truss and if it's in compression or tension. If we look here, we have 1, 2, 3, 4, 5 members that we need to solve for the force in. So we need the force in AD, AC, CD, BC, and AB. And given, really just the diagram is going to be important to us. So the next step will be the free body diagram step. Is this a statically determinate or indeterminate structure? If we look at the external reactions, we have a pin at B and a roller at A. So there'll be one reaction at A, and then a BX and a BY if we were to draw the free body diagram at B. So a total of 3 unknowns from the external supports. If we have 3 or fewer external reactions, it's statically determinate, and I recommend starting with the external free body diagram in that case. Again, you could jump right to drawing pins if you wanted to, but I recommend it's usually best to start with that external picture. So again, A is a roller, B is a pin, 3 unknowns. That leads us in the process that I recommend drawing that external free body diagram in that case. So we're going to draw one of the whole truss disconnected from those supports at A and B. We have one external load, the 300 pounds. And at A, where there was a roller, I'll have an AX. I actually know that AX has to point to the left because the roller is going to act just like a normal force. So the wall can only push on the roller, it can't pull. In contrast, though, at B, where we have the pin, that pin can pull it to the left or the right. It can pull it up or pull it down. So at the pin at B, I'll just assume the X component is right and the Y component is up. From this external free body diagram, we knew it would only have 3 unknowns, and we have AX, BX, and BY. And we'll be able to solve for all of them by writing equations based on this free body diagram. So we can start with the sum of forces or the sum of moments. In this case, because we have a pin at B, actually it's going to be easiest to start with the sum of moments around that point because we'll be able to immediately get one of our unknowns, namely AX. Taking the moment around B, BX, BY will not be in that equation. I will have a moment caused by the 300 pounds that's 4 feet away. That will be positive or counterclockwise around point B. And they'll also have a force at a moment due to AX that's 3 feet away. And we see that AX is going to cause it to spin clockwise, so this will be a negative moment. Because I started with that moment equation, I have only that one unknown AX. So I can solve AX immediately, is 400 pounds. If I head to the y direction here, and this was equal to 0 since it's in equilibrium. If I jump to the y direction, I have a negative 300, and I have my positive by. Yeah. Oh, sorry. So using equation 2, by must be positive 300 pounds. And 3, looking in the x direction, we have negative AX, which we now know, plus BX. So the BX must be equal to AX equal to 400 pounds. All right, now we'll go and draw these internal pictures or the pictures of the pins. So looking at all the pin choices we have, A, B, C, and D, which one looks like it will be good to start with? I started with D. It's attached to 2 members, and at D, I only have that one external force. So I copy all the external forces that are on D, that 300 pounds. There's no supports here. And I have to include what the members are doing to D. I'm going to, again, always assume tension here. I'll assume that AD is pulling to the right along its length, and that CD is also pulling on point D. This would go as a 3, 4, 5 triangle. So I can express this direction using a ratio triangle. That's my complete free body diagram for the pin at D, the external force, and the two forces that I don't know that are attached to it. Using this, I can write two force equations. Which one from the picture looks like it's better to start with? In the X, I'll have AD and a component of FCD. So I'll have two unknowns in that equation. So again, you can start there, it's fine. But if we look in the Y direction, 300 is given, and FCD is the only thing with a Y component. So I would say just from the perspective of doing this by hand, it's just easier to start with the Y direction. We'll have the negative 300 plus 3/5 FCD. And that allows us to then find the force in CD. 500 pounds, and that will be in tension. Now if I go to the X direction, since now when I'm writing this I know FCD, then this will only have one remaining unknown in the X. I have all of FAD, which I don't know, plus 4/5 FCD. Plugging in 500 for FCD, I can solve for FAD. I get negative 400 pounds, which means that FAD is in compression. Got my two equations from my particle equilibrium picture, so that's all I can get out of it. So I have to move on and now pick another picture to draw. So if I solve D, what looks like a good next choice? So A is good because there's only two members attached to it that I don't know, assuming I did not identify AC as a zero force. And I know the support at A as well. So drawing A, there are no external forces acting on A. I have AX acting on it, which I know its value was 400 pounds. And then the three members that are attached to A. FAB, FAD, and FAC. And here we know that FAC, I expressed it as, that's also going as a 3, 4, 5 triangle. Because the height from C to the line AD is 1.5, so the ratio still holds up as 3, 4, 5 for this. So again, that's my picture A. I know FAD from the previous step though. Looking at picture A, based on what I already know, should I take forces in the X or the Y first? Right, the X, because I have 400 and FAD, which I know, and then part of FAC, so I'll be able to find FAC right away. I have minus FAD, minus 400. Oops, sorry, this is not meant to be, it's a positive 400. And then I will have minus 4/5 FAC. I know that FAD was negative 400, so I have 400 minus 400. So I do get, by solving equation 6, I solve that FAC is 0. So it does confirm that was indeed a zero force member. So we were right if by inspection we went to immediately identify it as so. That was the x direction. And now in the y direction, that will be FAB. That's in the x, plus a component of FAC. But I already know FAC is 0. So actually it turns out that FAB is a zero force member. We couldn't identify that, though, based on our rules, but mathematically, that did turn out to be the case. Looking at what we were asked to find, we have FAB now. We have FAD. We have FCD. FAC was 0, so the last thing we need is FBC. I need one more unknown, so I need one more picture at minimum to be able to solve that. I can choose B or I can choose C to do that because both of them are attached to FBC. Right. I decide either one is okay. Actually, C would be pretty obvious because they're going to be equal and opposite. But actually, in my notes, I went with B as my last free body diagram. There's no external forces. I'll have Bx and By, which I erased it, but Bx was to the right of 400. By was up and 300. I have FAB, which we know is a zero force member, so I actually won't even draw it in the picture. And finally, I have FBC, which I am yet to find. Some forces, it really doesn't matter if I use X or Y here because I only have one unknown in my picture. So I'll just go with X in picture B. I will get a 400 minus 4/5 FBC. Solving 8 FBC must be equal to 500 pounds. And that will be in tension.